Hello everyone. Today we will study the corrosion prevention of the catalytic reforming depentanizer tower. The reforming process involves reactions like aromatization, cracking, and isomerization under the action of a catalyst. This produces lighter components with less than 5 carbon atoms and heavier components more than 9 carbon atoms. At this point, components with less than C5 and more than C9 need to be separated out. This allows the C6 to C8 components to enter the extraction unit to separate out triphenyl product. This is where the depentanizer tower is used. Let's look at the function of the depentanizer tower. The depentanizer tower is the fractionation tower after the reforming reaction. For units without aromatic production, the C5 oil is typically sent out as high-octane gasoline. Removing C5 components is to increase the gasoline's octane number. For units with aromatic production, removing C5 components is to reduce the non-aromatic components entering the extraction unit. This improves the purity of the aromatics and reduces the unit's energy consumption. Next, let's learn about the depentanizer tower and the stabilizer tower. The reformer stabilizer tower, as the name implies, removes components lighter than pentane from the reformate to produce stabilized gasoline. Therefore, in a reforming unit, the depentanizer tower and the stabilizer tower are the same tower. When producing feed for the aromatics unit, it's called the depentanizer tower. When producing stabilized gasoline, it's called the stabilizer tower. As shown in the diagram, following the depentanizer tower are the aromatic extraction tower and the solvent recovery tower. They are used to separate benzene from non-aromatic and to separate solvent from benzene, respectively. Now let's look at the corrosion prevention for the depentanizer tower. After the reformer feed enters the reaction system, the hydrogen chloride, water, and hydrogen sulfide it contains or generates will enter the fractionation system carried by the circulating hydrogen. When hydrogen chloride exists alone, it does not cause severe corrosion to equipment and pipelines. However, its corrosivity increases when it coexists with liquid water. One hazard of equipment corrosion in the CCR depentanizer tower is causing operational fluctuations. Ammonium salt deposition is relatively common in the trays of the reformer depentanizer tower. Generally, after tray blockage, abnormal fluctuations occur in the tower top pressure, bottom temperature, and sensitive tray temperature. This subsequently leads to poor separation efficiency and overlapping distillation ranges of the overhead and bottom product. After ammonium salt crystallization occurs on the trays, it causes insufficient vapor-liquid contact inside the tower. This affects the heat and mass transfer efficiency. Other hazards of equipment corrosion in the CCR depentanizer tower include equipment corrosion and blockage. After enrichment occurs in the depentanizer tower, the chloride ion concentration at the tower top increases. For the air cooler outlet, the temperature is typically around 50 degrees Celsius. This makes it prone to corrosion. If the dechlorination effect in the depentanizer feed is poor, it can lead to the generation of trace water in the system. This in turn causes corrosion in equipment like water coolers, air coolers, and reflux pumps. Let's examine the preventive measures for equipment corrosion in the depentanizer tower. To better ensure the dual functions of the reforming catalyst are matched and its performance is fully utilized, the water chloride balance of the catalyst must be effectively controlled in the reaction system. By monitoring the source of water, ensure the water content in the reaction system is controlled within a certain range. During the operation of the pre-hydrotreating reaction system, reduce the chloride content in the pre-hydrotreated oil. At the same time, control the chloride content in the system. Furthermore, the water content in the feed must be strictly controlled. Identifying problems promptly and taking correct measures are essential to ensure smooth production. This requires practitioners to have a highly responsible professional spirit and specialized, focused professional competence. The above is the content we learned about the catalytic reforming depentanizer tower. Now, here is a question for thought. Briefly describe the role of alkane removal in catalytic reforming. Alright, that concludes today's lesson. Goodbye.